Okay, I'm sorry. Didn't really talk about much to this point, but I'm now recording and I'll record every lesson and I'll put it on the D2L page. But I was just talking a moment ago when I realized I wasn't recording as of yet about this terms and acronym sheet. So I can tell you right now, see that one right there with an asterisk, basic? That is on the first test. What other one do you think is definitely going to be on the first test?
CPU.
Nope. You see that little asterisk? I'm giving you a hint. ASCII is going to be on the first test. You have to look that up. American Standard Code for Information Interchange. What's a byte, by the way? 8 bits. What's a bit? A bit's a light bulb. It's either on or off. It's this whole binary. That's why everything computer science deals with electric. It has an electric charge or not. It's on, it's off. It's a 0 or a 1. And that comes from base 2 when you count with zeros and ones. Okay. So then if I up it to, we're starting to deal with memory size, and way back in the 1980 when I started college, we didn't go much farther than kilobytes, believe it or not. But a kilobyte is going to be 1,024 bytes. 1,024, not 1,000. I fought with a trivia guy one night. He said, I'll accept 1,000 as an answer because he said, what's a kilobyte? I know, dude, it's 1,024. It is 2 to the 10th power. 2 to the 10th power. Right? Everything's in terms of light bulbs. What is a megabyte? 1,024 kilobytes. What's a gigabyte? 1,024 megabytes. You got the idea of what's going on? And again, that 2 to the 10th power is 1,024. Lots of light bulbs. Lots of light bulbs. A byte is 8 light bulbs, on or off. You're going to see a lot of stuff we do with binary as we go through and all these light bulbs and everything. So the first test is on chapters 1, 2, and 3, I believe. And that's these first 2 pages. And again, I would fill these out and know them for the test, not think you're going to just lay it there and look at it. You're not going to be able to do that. You have to know these things. And some of you may be able to go through and do 3/4 of them. Some might not, but I gave you a couple. Today we're going to get into all of this stuff in chapter 2, and with a little luck, a bunch of it looks familiar already. Okay, next thing I want to take a look at. I'm coming back to, where is it? It's here. It's our website, but I have to get to here. Can you see our D2L site? The video gave you a little tour earlier. Week 1, yeah, you have 3 assignments that are already passed. Okay? And this was available 2 weeks ago, this information, because I posted it on January 14th, told you could get into the class and so forth. And there's another copy of the syllabus. All right? And over here are those old videos. Today, I'm going to put this one right here, sections 2.1, 2.6, what we're talking about right now. Code listings were due today. Code listing 2 is next week. A couple of you had questions, but almost everybody did get the code listings done. I didn't get but maybe 3 emails asking about it. Y'all know where the Zoom link is. And you know what all of these things up here do. Hey, that was that intro video, so we don't have to spend time in class talking about it. Okay? So you went through and hopefully you took a look at chapter 1 stuff. And some of you know because you've already taken it. This is my view, not yours. But this quiz on chapter 1 is now available. This one is not recorded and has a lockdown browser. I need you to pass that quiz without asking your friend. I need you to pass all these quizzes. As you can see for tests, we have lockdown browsers. And I may have mentioned that in that intro video. You'll get more information from that as we get closer. So as well as the syllabus, the D2L page, I think we're moving right along. Okay. So I like to talk. I know I can't talk 75 minutes because I have 3 classes in a row today. So I need y'all to just jump in and ask questions and do what you need to do, because right there, you get out of this class what you put into it. And those of you that are comp sci majors, you want to get up and off and running and get started and be ready to roll. Yeah. Yeah. Okay. How we doing? Good? Stop sharing. Comes back to me. We have 15 in the class. 2, 4, 6, 8, 12, 14, 15. So 5 people didn't even show up today. Oh well, I track it and so forth. I'm thinking I'm pretty fair, but I'm sure 1 or 2 of you are going to rate my professor and say, he's a jerk. I don't recommend him. Pick anybody else. And, okay, you failed because you didn't do the work or you didn't study or something. That's usually where those people come from, and you all know it. So, okay, what do we want to do next? Da 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 da. I got this. I got this. Oh, we have a new student showing up to class. Pramish. Is that you, Pramish?
Hey, hello, good morning,
Good
Professor.
morning. You're 11 minutes late.
Yeah, I'm sorry, I went to pick up my friend. So,
Okay, that's excusable. Otherwise, I was going to make you tell a joke.
all right, I'm so sorry.
Okay, no jokes. All right. Next thing, we want to go to, and I'm going to share, and hopefully you are now at this point saying, I know what this is. This is Java. This is where I type programs up, and it's really easy to use. It's intimidating because I look up at their navigation bar and I go, holy smokes, look at all those buttons. But we hardly use any of them. Okay. So Joel, I'm stealing Joel's program. Joel is here. And this is what the very first one was supposed to look like. This tells me that you've been in the book, you have an idea of what's going on, and you're ready to roll. Up top, you see something called documentation. It is all orange. It starts there in beginning of line 1 with a slash asterisk. It ends at line 14. The compiler, which turns this into bytecode, the compiler ignores all of that. You don't see a reason for it now, but down the road it becomes important. How we use documentation in our programs. Okay. We have line 17, public class, and whatever I type here, you know you have to save your program as. You have to save it the name debugclinic.java, which is all I need when you upload stuff. I don't need that class. This is case sensitive. Capital D, not lowercase d. They're not the same thing. Everything in here is case sensitive. All right. When I have line 17, 19 and 32 go. You notice how 19 and 32 are indented? Not at all. They match. That's going to become important. The author does something I don't like, but whenever I type a left brace, I type a right brace. When I'm indenting, a left brace, right brace. Keep these straight. He puts this guy in line 22 out here at the end of this line, and I don't like it. And I've never met the guy, but I would like to tell him I don't like it. I don't think he would care, but I still don't like it. I like when they line up and I can keep track of. Because later we're going to have oodles and oodles of left braces and right braces. Good story. I used to call them curly brackets, but I had a blind student. I've actually had 2 blind students. They couldn't find it. So the blind student hits a button on the keyboard and it would say J, K, L, whatever they're doing. He could not find curly braces, curly brackets. So I had to retrain myself to make sure I called them left brace and a right brace. Yeah, line 23 to 29, they're all pretty. They're indented the same. By now, you know Prince put everything side by side by side. What's green inside of there, that's called a string literal. Okay, it prints exactly what's green. And then you see every line, well, almost every line ends with a semicolon. So if I really wanted to, I could write a program where everything is on one line. But we're not going to do that, are we? I mean, I could just keep doing this because the compiler, which by the way, that little green button up top there, I hit that if I want to compile and it says, uh-oh, we have an error. Wasn't saved correctly. These error messages are hard to understand right now. Later, you'll start to pick up, and doing those code listings are really going to help you pick up errors because you're going to type them in and see, I have an error, but then you figure out quickly how to fix it. Okay. So that was that debugging clinic. All right, I'm going to close this one. Any questions? Close, 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 close. All right, we're going to spend today typing. Almost every week, I'm going to be able to put you in groups at the near the end of class and make you kind of work on simple things and so forth. One of the things that I leave available for you is my Zoom site. So if I had Jacob and Alhaji and Kishab say, hey, how about the three of us get together and work on blah, blah, blah? And then Jacob says, well, he said we can use his Zoom site. How about the three of us log in Tuesday at 7 o'clock and then we can work on stuff? Yes, I'm allowing you to use my Zoom site anytime except Monday morning and Monday afternoon because that's when I have classes. But otherwise, you want to get together, you can. Oh, well, what if I want to know well, here we go. What if I want to know somebody's email address? Well, you have class list and you can email, for example, I want to send an email to Jefferson. This is something that you can do. You can contact each other. Remember, some of you are going to be in 121 together. Next semester, 161 together. The following semester, 162 together. So it's good to build those bonds right now and get to know each other. All right, I'm going to go back and you might want to type along because here's what I'm going to do. I'm going to start and I'm going to type in a program. Yeah, I am. All right, here we go. Excited. First things first. I want to do a file, new Java, and hopefully you're all familiar with that. First tip, Control L. Control L turns on line numbering. Control L turns on line. Okay. Slash slash. This is a type of documentation. Documentation. Nice. Slash asterisk. Asterisk slash. This is another type. You notice it's all in orange. You notice blank lines will help as we go through this. What might I put in here? I might put in my name. Blah, 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 blah. I might put in the date. Blah, blah, blah. This program teaches me a lot about chapter 2. Now, if you don't want to type, that's fine. One, you can always rewatch the video. Two, I will save what I'm typing and I'll put it on D2L for you. Okay? Yada, yada, yada. I need a bunch of workspace here. All right. First thing I need to do, as I know, is something along the lines of public class And I'm going to call this chapter, oh, no spaces, chapter 2. What is that called when I have upper cases at the beginning of words? Does anybody know what that's called? I'm going to put a note in here. Camel case. Camel case. There's also something called snake case. That's the one where we use the dashes or the underscores. Oh, you notice this is another way of doing documentation. I snuck it on out there to the right. To the right, to the right. Oh, sorry. All right, I'm ready to begin my program. Here is a left brace. Pow! And I'm so old school, I do a right brace right away because I'm not going to mess that up. Indenting, usually go about 3. This is something that you type over and over. Public, static, void, main, string, square bracket, args. And again, line 11 and 14 do not end with a semicolon. All right, so I got my main. This is called my main. And I'm going to go, pow, 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 pow. File. Save as. Where do I want to put this? I'm going to stick it in my downloads just to throw it somewhere I can find downloads. If I go too fast, slow me down. Okay. And again, you notice it's even making it easy for me. Chapter 2 with a lowercase c and a capital T, and I save it. Here's something I do a lot. I will now take this, compile and run it. Doesn't do anything, but I have no what's called syntax errors. I have no typing errors. But I do that a lot so that I don't get to a certain point and run it and have 94 errors. It's quick, it's easy. When I click the running guy, it will compile it and run it. The green plus just compiles. I almost never use the green plus. I use the red running man most of the time. Okay. So what do we do? All right. One of the things that I put at the beginning of every program, declaration section. You notice this is another line of code that's being ignored. All right. So what do you mean declaration section? All right. If I give you the equation x plus 2 equals 9. I'm just out here. I'm going to erase this. X plus 2 equals 9. What's your answer?
7.
7, right? 7. And when you were a little kid and you started learning your numbers back in 4th grade, you had your counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you added 0 and got the whole numbers. And then you did the opposites. So you had -5, -4, -3, -0, 1, 2, 3. What group of numbers was that? So as a result, x equals 7. And the group of numbers was called the integers. I almost typed omelet. I'm not hungry. What do I have on there by accident? Integers, right? We had integers. They were nice. What if I did this? X plus 2.1 equals 6. What's your answer?
3.9.
3.9. And that wasn't an integer, was it? That was something else. That was called a real number. That was called a real number. So when I'm dealing with these, sometimes I want x to be just a simple integer. Sometimes I want it to be a real number. So I have to say in my declaration section, hold on a minute. I need to say, I want to create a variable, an integer variable, excuse me, and we shorten it up with just int, and I want to call it num1. Okay, that's a little better than just x. It's a little more descriptive. Num1. Num1 gets the value. And it's kind of unique. So now in my program, waka, 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 I can say something like num1 is assigned the value of 8. Compile. No whammies, no whammies, no whammies, no whammies. It compiles and it's good. Instead of real numbers, I have a second data type. I'm going to do this. These guys are called my primitive data types. And we have 4 of them. They're the basics. The first one is int, num1. Is anybody ready to tell me the second group?
Is it double?
Double. Yeah. Instead of the word real, we have what's called doubles. Okay. So now num2, where am I? Num2, let's go. No, let's go Eagles. EAGLES Eagles. All right. Num2 can hold some, is assigned, by the way, that equals is called the assignment operator, a value 3.21. It's allowed to get that value. What if I want to display this? Well, by now, you should be familiar with the ever popular system.out.print. And what does system.out.print do? Puts it on one line. Let's see. Num1 has the value of, I'm going to leave a space there. Now I put a plus, and I'm going to print out what's being stored in the variable num1. They're also called identifiers. We'll talk later about what are the rules for creating the name of an identifier like num1. Okay, I'm going to run it, and pow, down here in the console window. Oh, I'm going to make a note. I'm going to make a note to self. Displays in the console window. It is for programmers, right? When we're writing our programs, we want to quickly see some output. We display it down here. But when we're writing code for somebody to use, we don't use the console window. We'll use something else. But there it is. Whoop, there it is. And again, if I wanted to print out num2 has the value of plus num2. Hopefully it'll compile and run for me all nice. And it does. Oh. Down in my console, I don't want that. What do I want? I'd like them to be on separate lines. So what puts in a carriage return is that ln. You should have. So you're all feeling pretty smart because you did the code listings and you're like, I did this. I know this. I'm feeling good about it, right? The ln puts in a carriage return. What is a carriage return, by the way? If I go down to my output, I now see it's on 2. Remember the old manual typewriters that weren't plugged in? They were typewriters. And you put the piece of paper in and it wrapped around a bar. Some of you may have never seen it. That bar is called a carriage. And you would type away, and when you got to the end of the line, you had to return the carriage to move to the next line. So that's why we call it a carriage return. It moves us to the next line. Okay, so I now have a place where I can store integers. And if you looked in the book, you can see the range of numbers that an integer can hold. Same with a double. And we'll look at that in a little bit. Why would I use integers? Why not just use doubles all the time and be safe? What's the advantage of using an integer? Well, one advantage is it uses a lot less memory. Because think of storing all these decimal places and everything. I need a lot more memory to put in a double than an int. And way back in my time, memory was an issue. Big time issue. All right, give me another one. What's another one of the 4 primitive data types? I had to do
Bool.
bool, right? Bool, Boolean, Boolean. Okay, this works great with binary because it holds a value of true or false. So I'm actually going to call this variable TORF. I like that. Semicolon. It gets a value of true or false. TORF gets a value of true. Notice how it turned it purple. Back in the day, everything used to be black, but this is kind of nice. It now holds a value of true or false. We're not going to do much with Boolean right now, but we're going to get into it later. And what's the next type? Char? And char is something that holds a character. So I'm going to just call this character 1. Okay? Some notes. Holds the value of a character, a single character. Use single quotes. And again, you can just sit and watch. I'm going to give this to everybody when it comes to use single quotes. So character, spell it right. Character 1 equals single quote F. Single quote F. We're going to learn about another data type called a string. We'll get to that later. But these are the 4 primitives. Okay, 1, 2, 3, system dot out dot print. I want a character return up there. So I'm going to make that println. I'm just going to make this one println as well. Here comes my string literal. The Boolean value is double quote plus, what did I call, or I don't want the Boolean. Let's go, just choose the character. We could do the Boolean if we wanted to, but character 1. I need more room, more workspace. Compile, please everybody work. Yes, there it is. The character value is, everything in green got printed. Character, da 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 da. Da 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 da. Somebody say da 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 da.
Da, 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 da.
Thank you very much. Okay, so that's a nice introduction, and that's a nice little program, and we ran it, it worked, and we feel pretty good, and so forth. So that was section like 2.1, 2.2. We even got started a little bit into 2.3, and we are having a good time, 2.4. And now we're going to jump into 2.5 and 2.6. How are we doing time-wise? Everything looks pretty good? I'm looking around. I'm checking my notes. I feel pretty good. Now, I'm not going to erase all of this and start a new program. But let's just pretend, in this case, we're starting a new program. All right? When you did your code listings, you did it right. You turned in a pile of different programs. I think it was 7 of them, right? You wrote 7 separate programs. Well, that was exactly what I want you to do. They're due before class starts, and you see exactly why. All right, everybody's happy. You now are saying, let's make this a little bit harder. So I already know what I'm going to do. So I'm going to create some variables. I'm going to create some new ones. num3, num4. Now you notice how I put more than 1 on the same line. That is absolutely allowed. Okay. Int, I'm going to create a couple more. Sum. I know I'm going to use that. All right, let's get started. I'm going to come down here and I'm going to do some processing. I got some work going on. All right. So what am I going to do? Well, I'm going to do something as simple as this. Sum, oh, no capital S. Sum equals num1 plus num2. Sum equals num1 plus num2. Now, whenever you're supposed to tell me I spelled sum wrong. That's half the fun, telling me what I did wrong in class. Let's make a little note here. I'm going to come out because the computer is ignoring these notes. Work on the right, assign to the left. All of my work is on the right of that equals. I'm going to make another little note. Equal is called the assignment operator. The equals is called the assign. It takes what's on the right side and assigns it to the left. Okay, I'm going to have my output section. And I'm going to do system dot println dot, or excuse me, I forgot the out. The sum of, check this bad boy out, double quotes, plus num1, excuse me, num3, plus space and space, plus num4, plus double quotes, is double, wow, sum. I want the words the sum of, I want the value of num3, I want the value of num4, and oh, what am I missing here? I need to do something like num3 equals 5, num4 equals 6. Just typing away. I'm hoping it runs and compiles. Oh no! That's because I want num3 here, num3, and num4. Now, why did this not work? This is good screw up. So when I put num1 and num2 here, it says, oh, there's conversion from double to int. Oh, num1 is an integer. Num1 is an integer. Num2 is a double. Num2 takes up a lot of memory. When I add these two, it gives me the result of a double. That doesn't fit into an int. So there's more memory being used on the right side than I can fit into the left side. But I want to go back to processing the basic arithmetic operators. And the one we're doing right now is just simply the plus sign. Okay. So now I want to take num3 is 5, num4 is 6, add them together, and display them in sum. Please work. Yay, compiles. Check out how pretty the output is. I didn't just output 11, did I? I did the sum of 5 and 6 is 11. Nice. Well, I think it's nice. Check this out. There's another one of our basic operators. Asterisk. What would get output in line 57 now? What would be displayed? Well, the first thing is going to happen is sum is going to get the value of 11. And in the next line, I'm saying sum gets the value of 11 times 2. You have all these arithmetic operators. My sum should be 22. Drum roll, and it is. Oh, so I can add, I can do all. Let's just get another variable in here, int total, just for kicks and giggles. Total equals sum times 3 minus num3 plus 6. Oh. Crazy, crazy, crazy. Now I hit insert again. Crazy answer for total. Plus, plus, and I want whatever value total has. What you think about that? What's total? This is why we require a math background. Yeah, buddy. No guesses.
Is it 67?
Drum roll, please. 67, excellent. Kudos. Kudos. Wow. Okay. Cool. So I have, well, there's subtract. So up here in my notes, I'm going to put I have subtract. And I have one more called division. There's going to be two types of division. Two types of division. Okay. Here we go. Here we go. System dot out dot println. I'm going to do this. Answer is double quote plus, let's see what we got here. I can do this. 55 divided by 8. Hope I can do this. What is 55 divided by 8? Drum roll. It is 6. 6. 6. Now, how do we get 6? This guy is called, well, I don't want to, I want up here, space, slash, integer divided by an integer is an integer. Okay, 55 is an integer. Divided by 8, which is an integer, gives me a result. Result is, I'm going to put the word result in here. Result is an integer. Oh, let's keep this party going. System dot out dot println. Answer is plus, let's do 55, which is an integer, divided by 8.0. Woo-hoo. Integer divided by a real result is a, let's change this word from real to double, because that's going to be our comp-sci lingo. Should be a double. 55 divided by 8.0 is 6.875, the exact answer. Nice. System dot out dot println. Answer is, now I could be doing all of this work up here in processing in lines of code, but this is just a learning tool right now. 55 point, whoops, 0.0 divided by 8. Now we have a double. Double divided by an int. Result is a double. I compile it again. I'm liking not having any mistakes. Yeah. So whenever it's a mixed data type, the answer is going to be the result of whichever one uses the largest memory. Like I said, double uses more memory than int. More. We good? All right. I'm going to have to start making people do thumbs up emojis so that I know we're good. Okay, arithmetic types. The plus up here in line 45 times minus two types of division. One is integer, one is real. One is int division, and the other is real division. Yes, Kason. Kason.
Yes. I just had a quick question. I was wondering, I know you said to use JGrasp, but other students had recommended IntelliJ for me,
Oh,
and I have used it. I had used it in a previous class before, and it worked really well for me, and I was wondering if you're okay if I still use that.
as long as when you upload a .java file. Because if it has that extension, I can come in and open it up in JGrasp. Or a lot of people are starting to use VS Code because you can use VS Code for Java and C++. You want to use IntelliJ, you can use that. Different high schools teach different ones. And so I'm okay with whatever, but as long as it's, and I should save, I haven't saved in a while, as long as I get a .java file. Yep, good question. I'm okay
All
with
right.
it.
Thank
Yep.
you so much.
Are you doing that right now?
I've been using IntelliJ, but I just wanted to clarify before I went any further because I was submitting .java files, but I just wanted to
Yep,
clarify.
yep. Okay, so under these arithmetic operators, and again, we're going to stay with this, we have something that's called, and again, I'm just adding notes here today, something called modulus. And this gives the remainder. Oh boy. This gives the remainder. Modulus symbol, which we could put up there if we wanted, is the percent sign. So how does modulus work? System.out.println modulus plus. So I'm going to do a couple examples. I'm going to do 15 modulus 4. That's not right. I'm still hitting the wrong keys. Modulus 4 system.out.println. Here's another example of modulus. Let's do 3 mod 4. Well, let's get some parentheses around that to keep it clean. Let's do one more. System.out.println modulus. And let's do 16 mod 4. Okay, so I'm going to get the remainder. In line 65, remember Control L turns line numbering on. What would be the answer for line 65? What's the remainder when I do 15 divided by 4?
3.
3. So let's hope our first answer is 3. What is our second answer going to be? How many times does 4 go into 3? None. What's left? 3. That one's also going to give me a remainder of 3. What's the answer going to be for the last one? So remainder is 3 is what we're hoping. Uh-oh. What did I forget? My double slashes. Remainder is 3. What's the answer going to be for this one?
0.
0. Hopefully you're doing math, or at least Compile. Boom, 3, 3, and 0. So we have good examples of mixed division and integer division. We have good examples of modulus. I don't know if you keep a notebook or not. This might be a program you can even print it out and keep track of in your notes. Okay, good. So we're starting to learn about all these arithmetic operators. This is great. We can do all kinds of stuff. I could throw this at you. System.out.println. Here we go. Let's see. I'm going to throw this one out at you. 8 times 7 minus 6 mod 4 slash 4.0. Uh-oh. What the heck am I talking? 8 times 7 minus, that's a little better. What are you doing? I don't want a new line. Minus 7 times 7 minus, oh, that's supposed to be a 6. Goodness gracious. Chomp on that for a minute. What's happening here is, just like regular math, you need to know your order of operations. Order of operations. What gets done first? The 8 times 7. What gets done second? The modulus. What gets done third? The time. Okay, so I'm going to make sure we're all on the right page. First thing that happens is we get 56 minus 6 mod 4 slash 4.0. Did the 56 first. Then it's going to give me 56 minus, what is 6 mod 4? What would the remainder be?
2.
2, right, slash 4.0. Then I'm going to get 56 minus, what is 2 divided by 4.0? .5? What's 2 divided by 4? That's a half, but we know the answer has to be in a double. Final answer, I'm hoping, is 55.5. Run and compile. Let the computer do the work for us. And it says I screwed it up. What doesn't it like? Cannot find what symbol?
Forgot the T.
T.
System dot. Oh, crap. Thank you. Pow, 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 pow. 55.5. That's right. That's right. Mm-hmm. That's what I'm talking about. Okay. Now, 3 more, and then I'm going to let you maybe kind of type something on your own. I don't know why I don't use cut and paste, because I'm messing up. 3 more system.out.println. What do I have against T? I don't know. Okay, so there's lots of code for Java that is written, that is stored in Java, that we don't use until we call for it. Otherwise, if I tried to compile and looked at all these libraries of code tucked away for me to use, it would take forever to compile. Well, it's called a class, and a class that's tucked away, and we're going to get into this. We're even going to write our own classes in chapter 7. It's tucked away is called the math class. And what I'm going to show you is the quick start of it. I'm going to say, hey, math class. So I type math. I want your code that does SQRT, which is the square root. I want the square root of 81. Okay. I want the square root of 81. Now, what will the answer be for the square root of 81?
9.
9. Almost. The value that gets returned returns a double every time. So when this displays and we display it, it should be 9.0. It's going to make it a double. But great, there's code written just like in your calculator that does the work for us. What else we got? Math dot here's one, pow. We don't have a caret to raise something to a power. Pow 8, 2. What do you think that's going to return?
64.0.
Perfect. This also returns a double. 64. Well, in fact, I'm going to stop for a second. I'm going to go and I'm going to get on where I don't know where I want to go. Let me go here for a second, and I'm going to go Math Java class. All right, let me come back. I'm going to share. This is a long day, folks. I just went up and Googled Math Java class. Oracle. If I click on in here and I start scrolling down, oh boy, there's absolute value. I could do math.abs. I could do, there's trig1s, the cosine. You notice over here on the left side is the return type. I want to go down to square root. There it is. Whoop, there it is. It brings in whatever value. It returns a double, just like we were working on. Oh, yeah? Let's find another one. Let's find something good. Ceil. I like Ceil, C-E-I-L. So I want to get out of here. I want to come back into, where is my hairbrush? Here it is. Ceil. Math.ceil 8.45. We're going to have to see what that does. All right, so the first one we think it's going to be 9.0. The second one was going to be 64. There's 9.0, 64.0. Check out what Ceil does. It rounds up. It actually rounds to the right, if you think about it on a number line, and rounded 8.45 into 9.0. I better save this. I better save this. Questions? Okay, I'm going to give you something a little bit to work on here. We already have, okay, so I'm going to do this. I'm going to declare a couple variables. The first one is going to be, let's see what I want to, int a, and check this out. I can give it a value right away. Int b equals 5. Int c, spelled it wrong, c equals 6. Okay? And you know this statement. A x to the second power plus bx plus c. You're pretty familiar with that. There's A, B, and C. And I said, oh, I know what this is. This is 1x squared, and again, carets don't work for us, plus 5x, oh, that's not a plus, plus 5x plus 6. And that factors into x plus 1, x plus 5. right? And if I even said, what are the roots? You'd say x equals -1, x equals -5. Does that sound about right? Yeah, yeah. So check this out. Double root 1. Root 1 equals, oh, come on. I know what you're doing. That's that -b plus or minus the square root of b squared minus 4ac all over 2a. Can you come up with that equation for root 1? System dot out dot println root 1 is root 1 is -1. So I need to come up with that arithmetic equation that's going to help me display root 1. Come on, man, that's hard. I know. I know. I want you to come up with root number 1. Root number 1. Well, Professor, I need to tell you, I don't really know what's going on totally. That's okay. We did cover a lot today. Oh, yeah. But you have a week to get all of this under your belt and to start working on the rest of chapter 2. So let's see. Oh, man. I'm going to come way out here to the end. And I know that it's going to be -b. The first one's going to be plus. The second one's going to be minus. -b plus or minus. And I had the square root. And the whole thing is over 2a, right? I'm going to do this. I'm going to break this down into something easy. And I'm going to go this part. Parentheses. The whole thing is divided by, what's it divided by?
2 times A.
Excellent. He gave me the answer in computer. 2 times A. So the whole thing is divided by 2 times A. I'm going to take advantage of these parentheses all I can. What will go in the beginning here?
-5.
Well, no, I don't know that it's 5. Just like I didn't know that it was A, because what happens if I want to go change those? I want
Is
this
it
to work to, go ahead.
is it -b?
Really close, Sophia. Remember what we just did with the 2A. Yeah, we're going to have to do this. -1 times B to get -b. -b, and then what did I say? We're going to do plus. Oh, I know what's next. What's next? Type a left, I'm going to type a right. Need to keep these bad boys straight. -b plus math dot square root. Math dot square root of what? What's inside the square root? B squared minus 4 times A times C. Parentheses, I think they're okay. My order of operations inside would be B times B first, then 4 times A times C second, then the subtraction third, then it would take the square root of all of that. Woo. I'm kind of nervous about compiling it. Please, please, root 1. Please, root 1b. Root 1 is -2. Oh, no, I didn't. This factor's wrong. Oh, come on. That's not right, you dumb 2 and 3, and yeah, oh boy. Did anybody know I screwed that up? Anybody? I'm just trying to keep my head above water. I know. Yeah, root 1 is -2. Might as well add this in. Double root 2. And I'm going to throw in root 2 equals. My mama didn't raise a fool. Well, she did. I have a brother, and yeah, brother. Control V. And instead of -b plus, it's going to be -b minus. Uh-oh. Minus. I'm going to do another copy, Control C, and paste. And I'm going to say this time root 2. My other root was -3. And pow! Questions? Questions? Wait till you start typing these bad boys up, and you're going to get error after error after error. I got a couple, and I've been doing this for 39 years. You're not that old. Yes, I am. No, you're not. Well, you seem pretty young. I am. You guys don't talk to me. I end up talking to myself, and it's not good. All right. We actually still have like 9 minutes, but I think your brains are full. You probably have typed most of this up, Like I said, I'm going to go post it right now. Clean some line spacing up here. Do you notice the indenting, the line spacing, the documentation? All of this makes for a more easy to read program. Maybe you added some notes in here as well, like, rounds to the right. Yeah, pretty good day with notes. Okay. 16 showed up, 14 did not. Actually, I think, or 4, excuse me. I think one of those 4 is dropping the class. He has a conflict. So 3 didn't show up. But any questions? Now, had we had a little more time left, I would have had you figure out the roots in small groups, and you could get in there and talk to each other and say, that was a great class. No, it wasn't. It was awful, whatever you have to say for the first day. But, you know, 1 day is down, and I think we have, well, actually 2 weeks. But once this week's over, but 12 left. Pretty soon I'm going to see, well, we have 10 weeks down and only 3 to go. And you're going to be like, oh. Today was a lot. Today was meaty. You know, you have time to go back over it. Hopefully those code listings, you now seeing why I make you do those and not have a second class. You come in with those code listings and you're like, yeah.